Right, so this is a little power supply for a TV monitor, well, computer monitor rather, and I've had to break into it. It got a bit wet. This isn't mine, it's one of the kids. Somehow it got wet. I think it had a flood. Surprisingly not in my house, anyway. And you can see it's got wet inside there. Apparently they actually tried it afterwards or something, and they could feel it giving them a shock when they picked it up. So I thought that was probably quite a bad clue to start with. And yeah, it's full of water. It doesn't smell very good, and well, it's all wet inside. I wouldn't say full of water, but it's pretty dirty and doesn't look particularly great. As you can see, it's got like sludge there, and this is because of the corrosion that's on the inside. It makes you wonder how long ago that happened. Anyway, I've got to try and get this board out, and I'm going to give it a clean. Now, I haven't discharged any capacitors, so I'm being really careful what I'm touching, because that would be bad. Insulated screwdriver. Let's leave her out with that. Then I can try and discharge capacitors and stuff like that. Oh, look at the state of that. Okay. Yeah, this might be a waste of time. Insulated screwdriver. Let's like short that cap out, and there's some more caps here. Short them out. Just want to make sure it's all dead, because it's probably stuffed anyway. But I just want to make sure I'm not going to kill myself in the process. Right. Look at the state of that. Yeah, that's pretty screwed. This is why when something gets wet, you don't turn it on or plug it in to see if it still works. No, because until you do that, it's not actually broken. It's broken when you turn it on or when you plug it in. So if it's wet, leave it alone, give it to someone that knows what they're doing, and get it dried out properly. This is 240 volts comes in this thing, and you can see here it's arced across here. You can see burn marks here where it's been arcing. That looks like it's burnt that track. Yeah, it might just be on the surface of the board there. Hopefully it's done no other damage. It might be able to resurrect it. I shall try it, but I'll give it a clean and see what it looks like underneath all the crap. And but yeah, this is why you don't plug it in to see if it works, because until it was plugged in to see if it worked, it was probably still okay. Anyway, yeah. I'm even tempted just to not bother, but anyway, yeah, have a good one. Alright, so it's got some burnt out parts on here, which means I won't be repairing it, but I thought I'll give it a clean anyway, just to see how bad the damage is, because this could be entertaining. I might need a little toothbrush for that. But yeah, it's done a lot of arcing, and yeah, it's just pretty damn messy. See how much damage it's done just in a short time. It's being really hard to clean off. So most of it's around this area here, but not all of it. So let's just see if I can get all the dirt off it. Oh yes. So there's two parts there which are burnt out, surface mount, and there's a trace that looks like it burnt out. It looks like it. And that's that big 400 volt capacitor just there. So I think those ones that are burnt out are actually the ballast across that capacitor to discharge it. So that would have definitely still been live when it was opened up, because there's nothing to discharge the capacitor. That part's failed. Probably because it was powered when it still had water in it, and then it's shorted out through those and it had something had to give. Yeah, it's. I can't see any other actual damage there apart from that. But yeah, it's not going to be good. It's, you can see the corrosion across everything. It's instantly corroded. A spark gap there. But it's just awful, really. It's just really yuck. I think that track there is burnt out too, actually, just there. That's got hot. You can see the coating's peeling off. So that track there has got hot. So that's probably the output there. Runs through that track to the capacitor. Was it the other way around? No, it's the other way around. That's the input that side. Of course it is. So that's the input that side through the bridge rectifier here, which then converts to DC, which is all corroded on there. That's all burnt out. Through that there, which looks like it's got a bit of solder on there to thicken that track up, give it more higher current. This is obviously shorted then because that's got hot, that track just there, because it's lifting the coatings off. So that stuff up here is then blown, most likely. We've got a transformer. This is like it's got hot over here as well, and here. So yeah, the whole thing's going to be stuffed. But, yeah, let's give you a better look. There you go. Always looks better when it's got a fresh coating of alcohol on it. But you can see, I'll get something to point with. See those resistors there, we burn out. Those will be resistors because that's got that big 400 volt cap, 50 volt cap with the isolation slot in there. So that's 400, at least 400 volts coming out of that bridge rectifier, wasn't it? Was it 1.4 more than standard? So 50% more. So yeah, it's been 400 volts. And so those are burned out. So that's obviously shorted on that supply coming in. That's corroded there. That's lifting off here. And all this is looking a bit dodgy too over here. It looks like it's quite bad. This is all corroded. So it's probably electrolysis effect from the water being in there. Yeah, it's certainly not recoverable. I mean, you can see this, all the coatings come off on these tracks, like this one here will come off, that's will come off there. So those have been getting hot and actually hot enough to melt the solder resist off, or solder mask. It's all come off. So yeah, it's just everything's corroded, it's stuffed. So, anyway, that's why I don't plug something in when it's wet. A good one. Okay, so what I'm going to do here, you will notice there's power cord plugged in here. That's because I'm going to do something silly, dangerous, yeah, maybe. I'm taking some precautions. Now, this is just the output cable, you can ignore that. This is 240 volt main is going to come in. Now, all of my gear, including my entire house, runs through an RCD. Alright, so that will cut out like that if there's an issue, which is going to be a problem. However, this is only a 2-pole connection, so RCDs do not work on it. Right? But if there's an issue where I'm earthed and I may be in a dangerous situation, at least I'll be protected. So that's the main thing. I've got an RCD in this room, I've got RCD on the wall, and I've also got RCD on the main house. So it's like triple RCD protection to this bench. So I'm confident it's fine. Now this may blow up. It may go bang. It may catch fire. I don't know. I'm going to plug it in. Now I get a bit of a clean on the bottom, as you saw. I've done a bit of a clean on the top, just a rough one. But I thought, right, I'm going to plug it in and see what happens. It's likely to go bang. And if it does, it's going to make a great video. So if this never gets published, then I'm dead. But it's unlikely to happen. Yeah, it's not likely to happen. I'm going to be out of the way. I'm not going to be anywhere near this bench over here. I'm going to be a metre away at the other end of this cable, plugging it in with my eyes shut, probably. I just worry about flames coming up and burning my camera, but that's another story. Right, so let's give this a go, and let's make this a little bit. You ready? I'm not. Here we go. This will turn your RCD on. This one is one that trips out mainly by itself. Right. Moment of truth. Does it go bang? No bang. Okay. So it hasn't gone bang. Has it gone fizz? No smoke. No popping. RCDs haven't tripped. Well, like I said, that probably wouldn't do anyway. So what I might now do. So this is live. This is like 400 volts right here. So I've got to be careful. I'm going to check the other end of this power cable here and see if there's any voltage coming out. And if there is, let's see what it is. I was actually half hoping for an explosion, because that would have made a good video. I've been on the electro boom level of productivity. Right. So connector on the grip. I'm not going to be touching anything myself, obviously, because it could be shorted to the mains or who knows what. Alright, so let's just check in there and see what we're getting. We're getting 14 volts. The bloody thing's still working. That is 14.3 volts. Wow, that is surprising. Okay. It actually still works. It isn't completely stuffed. Wow. Okay, so alright, in that case I will continue cleaning it up. And yeah, I need to discharge a capacitor when I unplug it. Right, so I'm not dead, it didn't blow up, and it still works. Strangely. Have a good one.